Hi, I'm going to make a video key for exit ticket, 13.3. So what's the probability of getting heads on a coin and also rolling two 20s on when you roll a 20-sided die? Okay, so the probability is going to be of heads, then 20, then 20. Okay, these are independent events, so we don't care about replacements, and there's no issue about order at all. So we're just going to have the chance of getting heads, which is 1/2, and then the chance of getting a 20, which is 1 out of 20, and the chance of getting a 20, which is again 1 out of 20 on a 20-sided die. So you're just going to have the probability is going to be 1 out of 2 times 20 times 20, which will be 800. So that's the probability of getting that. And if you want to see it as a decimal, sure, we can do that. 1 out of 800 is going to equal 0.00125. Okay, so that'll equal 0.00125. No need to round here because it doesn't go on forever and it's not a particularly long decimal. To make that a percent, it'll be 0.125%. So not very good chance of that. What's the probability of not rolling a multiple of 5 on a 20-sided die 3 times in a row? All right, so what you got to figure out right now is how many numbers on a 20-sided die are not multiples of 5. So 5, 10, 15, and 20 are forbidden. So basically, this is the probability of not 5, 10, 15, or 20 3 times in a row on a D20. So that's not the formal language, but I'm giving it a descriptive language there inside there. So the probability of not getting a 5, 10, 15, or 20 is going to be 20 minus 4 over 20. So that's 16 out of 20. These are independent events, so it's 16 out of 20 and times 16 out of 20. Now, since these are all the same factor, you could have written this as 16 out of 20 to the, not squared, to the third power, since there's 3 of them. Okay, so let's find out what that equals. So I'm going to end up with a decimal version up here first. Okay, so 16 out of 20. Cubed is going to equal 0.512. So it's not bad chances. So that's going to equal 0.512 or 51.2% chance. Okay, I'm going to put that as a fraction now by doing this. I'm going to deal with 16 cubed. That'll be my numerator, 4,096. Okay, so that's 4,096 out of, and now we'll deal with 20 cubed. 20 cubed is going to be 8,000. I don't need a calculator for that, so it's 2 times 2 times 2 and 10 times 10 times 10. And that is certainly reducible. So let's reduce that a little bit. 8,000. I can definitely factor 8 out of 8,000, and I can factor 8 out of 4,096. So I take that in half and half and half. So that'll be 1,000. So 2,048, 1,024, and then 512. So that's 512 over 1,000. Now you can see where that 51.2 comes from. We can take it a bit further because 1,000 is 8 times 125. Let me confirm that really quickly. 8 times 125 is 1,000. Okay, so I can factor another 8 out of top and bottom. So the numerator in half and half and half, so that's 256, 128, and 64. So 64 over 125. And I can't reduce that any further. I'm just going to confirm that 64 over 125 is still what I had there, and it is. Okay, so If you had gotten it simply to 51.2% or this reducible fraction and knew you could reduce it, that's good. And I hope that helps.